In this video, we're continuing our Binance Algo bot series. In part 1, we created our Binance API keys on the exchange, copied the API key and secret, and used them in Python to connect to Binance. We tested that connection by requesting our account information, so we know our bot can talk directly to Binance, read balances, and later place trades automatically. Now in part 2, we're going to use that same connection to check our balance and download clean historical price data for our backtests. Let's walk through the code step by step. First, at the top of the script, we import the libraries we need. We import pandas as PID, which we'll use to work with our price data in table format. We import client from Binance, client, which is the Python wrapper that makes it easy to call the Binance API. We import time, which we'll use to pause between requests so we don't hit Binance rate limits. And we import DataTime from the DataTime module to handle our start and end dates for downloading data. Next, we define our API credentials and create the Binance client. We set API key and API secret to the values we created on Binance. Then we create the client object with client equals client, API key, API secret. This client is the main object that our bot will use to talk to Binance, to check balances, request historical candles, and later send orders. In a real production project, you should never hard-code your keys in plain text like this. You would store them in environment variables or a separate config file. Right after that, we do a quick connection test by calling client-get-account. This fetches our account information from Binance and returns all the details about our balances. We store it in a variable called account, which we'll use in a helper function. Now let's look at that helper function, print balance. This function takes one argument, the name of the asset you want to check, like BTC or USDT. Inside the function, we first convert the asset name to uppercase, just to be safe. Then we call client-get-account, again, to make sure we have the most up-to-date snapshot of our balances. The account object has a field called balances, which is a list of all the coins in our account. So we loop over account balances. For each item, we check if asset matches the asset name we passed into the function. When we find the matching asset, we read two important fields, free and locked. Free is the amount we can use immediately, and locked is the amount held in open orders. We convert both free and locked to floats, so we can do math with them. If the asset is BTC, we do something special. We call client get symbol ticker symbol equals BTCUSD to get the current BTC price in USDT. We convert that price to a float, and then multiply the BTC amount by the price to get an approximate value in USDT. Finally, we print a line showing the free BTC, the locked BTC, and their approximate value in USDT. If the asset is not BTC, we simply print the free and locked amounts without converting to USDT. At the end of the loop, if we never found that asset, we print a message saying that the asset was not found in the account. This function is mainly for diagnostics. Before we download historical data or start trading, we can quickly run print balance, BTC, to confirm that the connection works and to see our BTC balance. Now let's move on to the most important part of this video, the getHistory function. This function is responsible for downloading historical OHLCV candles from Binance and converting them into a clean pandas data frame. The function takes four arguments, symbol, interval, start, and an optional end. Symbol is the trading pair, for example BTCUSDT, ETHUSDT, BNBUSDT, or XAUUSDT. Interval is the time frame, like 4H for 4-hour candles or 1D for daily candles. Start is the start date as a string, for example 2020-40-101. End is an optional end date. If we pass it, the function stops once it reaches that date. Inside the function, we start by creating an empty list called allBars, which will store all the raw candles we get from Binance. Then we convert our start date into a timestamp in milliseconds. We use PD to DataTime start timestamp to get the timestamp in seconds and multiply by 1000 to convert to milliseconds because Binance expects times in milliseconds. Next, we enter a while true loop. This loop will keep requesting data from Binance in chunks until we reach the end. Inside the loop, we call client getHistoricalClines. We pass in the symbol, the interval, the start time as start str, their end str, and we set limit equals 1000. Limit equals 1000 is important because Binance will only return up to 1000 candles per request. GetHistoricalClines returns a list of candles. If Binance returns an empty list, it means there is no more data, so we break out of the loop. If there are candles, we extend our all bars list by adding these new bars to the end. Then we update our start TS to the open time of the last candle we just received, plus 1 millisecond. This ensures that the next request starts right after the last candle, and we don't download overlapping data. To be gentle with the Binance API and avoid hitting rate limits, we add time, sleep 0, 1, which pauses the loop for 1/10 of a second between requests. Finally, if we have an end date, we convert that end date to milliseconds and check if our new start TS has reached or passed that end time. If it has, we break out of the loop, because we've downloaded everything we need between the start and end dates. After the loop finishes, all bars contains all the raw client data returned by Binance. Now we convert this raw list into a pandas data frame. We pass all bars to PED, DataFrame, and we provide the correct column names in the same order that Binance returns them. These include open time, open, high, low, close, volume, close time, quote asset volume, number of trades, taker by base asset volume, taker by quote asset volume, and an ignore field. Once the data frame is created, we add a new column called date. We convert the open time from milliseconds into a proper data time using PD to data time with unit equals ms. Then we set date as the index of the data frame using df, set index, date, in place equals true. This means that each row is now indexed by its opening date and time, which is perfect for time series and backtesting. Next, we keep only the columns that we care about for our strategy: open, high, low, close, and volume. We cast these columns to float to make sure they are numeric and ready for calculations, indicators, and any kind of strategy logic. Finally, we return this clean data frame from the function. So getHistory gives us a reusable, powerful tool. We can call it for any symbol and timeframe we want. For example, we can call it for BTCUSDT 4-hour, BTCUSDT daily, ETHUSDT 4-hour and daily, BNBUSDT 4-hour and daily, and XAUUSDT 4-hour and daily. All of these will come back as neat OHLCV data frames, ready for analysis and backtesting. After defining our helper functions, we test the connection. We call print balance BTC. If this prints our BTC balance without errors, we know the API keys are correct and Binance is responding. Then, in this example, we set up variables to download history for a specific symbol. We set symbol equals PAXGUSDT, interval equals 4H, start equals 2024-0101, and end is set to today's date using data time, now, SDRF time, %Y%M%D. Then we call df equals getHistory, symbol, interval, start, end. This line triggers the whole download process and returns the historical candles in a data frame called df. Once we have our data frame, we save it to a CSV file. We build the file name dynamically using an f-string. CSV filename equals fmt5 symbol data h4 CSV. You can see that the file name includes the symbol and the time frame. Here we use data h4 to indicate 4-hour data. Then we call df to CSV filename to write the data to disk. At the end, we print a confirmation message showing where the file was saved and how many rows were retrieved. We print data saved to, with the file name and rows retrieved, with the number of candles. This gives us a quick sanity check that the download worked and that we have a reasonable amount of data for our backtests. To adapt this script for the markets we want in this series, we will repeat the same process for each symbol and timeframe. For example, to download BTCUSDT 4-hour data, we would set symbol equals BTCUSDT and interval equals 4H, keep start 2024-0101, set end to today and call getHistory. Then we save it as something like MT5 BTCUSDT H4 CSV. For BTCUSDT daily data, we change interval to 1D and save it as MT5 BTCUSDT D1 CSV. We do the same for ETHUSDT 4-hour and daily, BNBUSDT 4-hour and daily, and XAUUSDT 4-hour and daily. By the end of this process, we will have a set of CSV files covering all the instruments and timeframes that we want to trade. The key idea is that this episode is about data preparation. We connect to Binance, verify our balance, and then download clean OHLCV datasets for BTCUSDT, ETHUSDT, BNBUSDT, and XAUUSDT on 4-hour and daily timeframes. These CSV files will be the foundation for the next part of the series. In the next video, we will load this data back into pandas, design a trading strategy, and use these exact historical prices to backtest our strategy and see how it would have performed in the past. If you're finding this series useful, make sure you subscribe to the channel, like the video, and share it with someone who's also interested in algorithmic trading. Follow for more content on Binance bots, backtesting, and trading strategy development. And if you missed it, go back and watch part 1 where we set up the API keys and the initial connection to Binance, so you can follow this series from the beginning. Download the Python file from the link in the description below. Just add your own API key and API secret, and you're ready to run it.